All right, I'm Mark Hill again, and I'm happy to be back to my rightful place as the only bow tie up here instead of three in the last panel. We're going to have now a very exciting panel on data, algorithms, and fairness. And what I'm going to do is introduce the moderator, Nadya Bliss, and then she is going to run the panel. So Nadya is a Director of Global Security at Arizona State University. She spent a long time at Lincoln Labs as Director of Computation and Analytics with strong connections to DARPA, including serving on DARPA ISAT, which is Information Science and Technology. I also served on that. So she comes with us with a great perspective with great connections to national security. Nadya.
Thank you, Mark. So let's see, if I press buttons here by accident, I apologize for that. So for those of you that were here for the previous panel, how depressed is everybody feeling? Like pretty depressed? I'm pretty sure it's going to get a lot worse in this panel before I'm hoping it'll get a little bit better. So first what I would like to do is I'd like to actually acknowledge Liz Bradley, who was the organizer of this panel. She unfortunately couldn't be here today. She's in London giving another talk. But she really pulled this awesome group of humans together. And I would also encourage everyone to go to the CCC webpage and read the white paper that Liz and Solon and a few others helped co-author on big data, data science, and civil rights. So one of the things that I actually noticed about our panel is nobody is kind of a traditional computer scientist. And one of the things that's sort of interesting that's called out in this white paper is the importance of interdisciplinary research, and particularly connecting folks that really deeply understand the civil rights challenges with the folks that understand the computing and computer science challenges. And I think all of the panelists here can really add a lot to that conversation. So last week, so I'm also really excited that this topic is actually getting a lot of attention. Last week, I was at the University of Michigan. They recently stood up a data science institute, and they do an annual symposium. I was one of the speakers there, and the symposium theme this year was a data-driven world, potential and pitfalls. And I appreciate that as a community, we're starting to understand that sometimes we should think about some of the potentially unintended consequences of the very rapid pace of innovation, which is awesome and really positive, but there are these other potential pitfalls. So there was also Cathy O'Neill. She's the author of Weapons of Math Destruction, and one of the things that I really liked about her formulation of some of the challenges, as she said, so what makes an algorithm a weapon of math destruction is basically it has these three properties: widespread, mysterious, and destructive, which also spells out WMD, which she said was not on purpose. I do not believe that. I think the speakers here are actually addressing all aspects of that, which again, I think is going to make for a really exciting conversation. The other thing that I wanted to call everyone's attention to is there was a Wired article that came out on October 18th, basically calling for government to stop using algorithms as black boxes. But it was also, and Kate Crawford's research was mentioned there, there was also some challenges called out, basically saying that it's very hard, again, because it's such an interdisciplinary nature problem. So we'll address some of that as part of the conversation. So with that, I'd like to introduce our first speaker, Professor Solon Barocas. Did I do that right? So he's an assistant professor in Department of Information Science at Cornell University, which is my alma mater, high above Cayuga waters with its waves of blue. So his research, I wasn't going to sing, I can't sing. So his research explores ethical and policy issues in AI. in artificial intelligence. He's also done work with Microsoft Research, the Fairness, Accountability, Transparency, and Ethics in AI group. And his PhD is from Department of Media Culture and Communication at New York University. So the focus of his talk will be on basically fairness and machine learning. And I just want everybody to welcome Solon. See if I can do this. Yeah, it's right there. And then view, full screen mode. Here we go.
Perfect. Thanks so much for that kind introduction. Hi, everyone. So I'll tell you all a little bit about what is now a somewhat developed, although still emerging field that goes by the name sometimes of fairness and machine learning, and it addresses the kind of core normative problems that I think motivated this panel. This is a community that a few of us, including actually Nick, who's spoken at one of these events, have been developing over the past 4 or 5 years, and it is, in fact, very interdisciplinary, involving people from largely computer science, but also adjacent fields, and even lawyers and policy people. And so we have this annual workshop attached to a lot of the machine learning conferences that is trying to push these concerns around bias and fairness into the mainstream of the set of topics that people are researching in these kind of core areas of machine learning. And I'll start by trying to explain to you what are some of the sources of bias that make this actually something worth considering, something worth actually thinking carefully about. But before I do that, I also want to acknowledge that while a lot of what I'll talk about in the next few minutes is trying to describe mostly these unintentional outcomes that can happen when we use these tools, a lot of people in these fields also recognize that there are profound upsides to using data to make all sorts of very important high-stakes decisions, including, as I think we'll hear later in the panel, about things in the criminal justice system, and things like hiring and credit. So the work I'll try to describe here is not to say that we don't want to actually move decisions to a more empirical footing, where there really is an opportunity to vindicate important civil rights, but that we also need to recognize that by simply using data to make decisions, we don't get there. We actually have to be a little bit more thoughtful about it than that. So let me explain to you why that is. So I'll walk through a couple different reasons, and I'll give maybe some examples to go along with each. So there really are, when we're thinking about machine learning, many possible sources of bias that would result in a model that exhibits some kind of objectionable or discriminatory bias. And if you can think of machine learning as a way of teaching a machine to make decisions by exposing it to many examples from the past, where it then finds some reliable pattern or basis to make inferences in the future, you can understand that the data that we use to train these models are fundamental. Right? So one thing that is maybe self-evident to those people who come from the social sciences, or specifically from economics, are questions about whether or not the variables, the features we rely on to make these kinds of distinctions or inferences about people provide sufficiently granular information that we don't needlessly subject certain populations to higher error rates than others. So this is what is often known as statistical discrimination in the economics or social science literature. And to give this a little bit of concreteness, what you can imagine is something like this. Historically, redlining was politically motivated. It was a way to kind of obfuscate the fact that often, in fact, government was in the business of trying to deny mortgages to the black community. But you can imagine, and the way that they did this is by saying there are certain areas in the map, often in a city. There are very famous maps of Philadelphia, for instance, where certain areas of the city are circled as areas where they will refuse to actually give mortgages. This was sort of relying on a known proxy for race. So certain neighborhoods were disproportionately black, and so by refusing to service this neighborhood, in effect, you're refusing to service black customers. Here, though, imagine a scenario where it's not intentional discrimination, but instead all we have, the most granular information we have, are the average repayment rates per zip code or census tract or whatever kind of unit we want to think of. And because there might actually be, on average, differences between these census tracts or these zip codes, you might think that a rational creditor will favor those areas where the average rate of repayment is higher and disfavor those where the average rate of repayment is lower. Right? But of course, even if we understand that there are group differences there that justify that behavior, it does not mean that people who reside in the area where the average rate of repayment is lower can't actually be a good candidate for credit. Someone in that zip code actually might go on to repay their loan. And by relying on this very coarse grained information, just what the average rate of repayment is for zip codes, we needlessly subject certain people in those areas that happen to have this higher average, lower average rate of repayment. So this is a way of kind of describing how you could have unintentional redlining, where there isn't a motivation to rely on a proxy, but by simply lacking additional information, we're sort of discrediting an entire area as being an unreliable candidate for credit. A different problem that has motivated a significant amount of work, and this is one that was first observed by my colleague Moritz Hart at Berkeley, is that by definition, we will have less information, less examples in the training data of minority populations. So even if you have a proportional sample of the population, there will just be fewer examples of the minority population than the majority population. And anyone who does machine learning will know that generally speaking, the more examples you can use to train these things, the more accurate its predictions. And so by definition, if we're going to have fewer examples to learn from with minority populations, it's likely to be the case that the accuracy of our model will be less good for minority populations than majority populations. This is an important caveat here, is that this will apply only though when the actual predictors of some behavior actually differ for the majority population than the minority population. If it turns out that the same pattern applies in terms of what's a good predictor of default for the majority and the minority, this doesn't matter. But when there are differences, then this is actually a really big problem. A separate problem is when we actually have a skewed sample. So again, think of standard things you learn about in statistics. If you don't have a proportional representation of the population and the data you're using to train your model, you can draw all sorts of faulty inferences or conclusions from it. And this can have some pernicious effects. So for instance, if you think about predictive policing, this is something that people have, this issue is something that people focus on in particular in the context of predictive policing. The worry here is that we don't actually have a perfect representative sample of the incidence of crime across a particular city. We tend to have a sample of where the police were deployed and the types of crimes that are likely to be reported. And that is an imperfect measure of the true incidence of crime across the city. And yet, if we use that as a way to make predictions about where a crime is likely to happen in the future and devote police resources to focus their attention there, the problem here is that we will fail to observe crime where in the past we already had a deficit of examples or observations, and compound this problem by actually devoting more and more resources to where we are actually in fact discovering crime, because in fact there is crime happening there, but limiting our ability to find that there is crime happening elsewhere. So this is a way in which this kind of standard problem of sampling bias or reporting bias, when used to make predictions and drive decisions in the future, can have this feedback loop. A slightly more subtle case here, though, is what I'm calling tainted examples. So one thing you might want to do, for instance, is try to figure out who to hire. And one way you might go about this is to look at how past employees at your company have tended to perform, and you might look to their annual review scores as a kind of obvious source of data. And so you might want to say, like, well, what are the qualities of my employees that happen to best predict whether or not they get a high annual review score, okay? So what is problematic about this is that we know from social science research that annual review scores, despite the fact that they're highly formalized, are also subject to all sorts of bias, meaning human bias, right? It could be the fact that there's implicit bias. People are not fully aware of the fact that they are judging someone subjectively in a way that incorporates certain ideas about who they are as a person, like their race or gender. Or worse, it could even be outright prejudice, right? We can have scores that, seem like some objective measure of someone's performance, but reflect some prejudicial view of the person performing that assessment. And if that is being used as ground truth to train a model to make predictions about other people with similar qualities, the model you've developed isn't going to predict how those people will do in the future. The model is going to predict how a human would assess those people in the future, right? Or specifically how these humans who have been at the companies would assess this person in the future. And so what this is showing is that it's not about sampling bias or these other kind of subtle problems in the data collection process. This is actually the fact that the examples we have, the labels given to examples, encode bias on the part of humans. And so this is a very tricky problem. And here, the other thing I'll quickly discuss is that there may even be situations where you've taken lots of efforts to ensure that your decision does not consider these protected attributes like race or gender or disability, and so you feel confident that your decision is going to be fair just by virtue of not considering these things directly. But as our data sets become more and more multidimensional, it's very hard to actually ensure that these particular characteristics are not reflected across the many other observable dimensions that we do consider, right? So for instance, my taste in music, the way I dress, all sorts of consumer patterns end up being highly related to these kind of fundamental things like race and gender and age and so on, such that even when you're making decisions on that basis, indirectly you are also possibly making decisions that reflect these kinds of protected characteristics. And so it can be very hard to decide at what point that is problematic. Does it need to be a perfect proxy for race, even if it's largely predictive of this thing you care about? At what point do we actually see this as being a challenge? And then finally, I should just acknowledge, although I think this is a much less serious concern, is that these tools ultimately let you do that intentionally. If, for instance, you wanted to be able to infer someone's race or gender from these kind of correlated facts, these tools are eminently prepared to do that, right? They'll find any possible ways to reconstitute this absent variable. And what is problematic about this is that then what it allows people to do is to say, well, I don't even collect information about your race or gender, so therefore my decision can't possibly be discriminatory. But these tools are very clearly able to actually figure out ways to infer it instead, and so it makes the question of proving that there is potential discrimination far more difficult. This is my kind of quick survey of a lot of well-understood sources of bias, but let me tell you a little bit more about them and try to provide some kind of categorizations that make this a little bit more interesting. So I said at the start of the talk that much of this is largely unintentional, but in fact all of this is unintentional except for this very final case. Right? No one who's actually building these tools sets out to make them discriminatory. You can, in fact, be someone who is making best efforts and who is even committed in principle to advancing and protecting civil rights, but fall victim to all of these problems. And that, I think, is the key issue that motivates a lot of the concern in this area. Even well-intentioned actors can fall victim to these problems. This gets even more complicated. So in the first two cases, when we have a way to kind of evaluate the performance of these models, and in particular, this is the next slide, when we actually know the protected attributes of the people being scored by these models, so if you know, for instance, the race or gender of the people that are being scored, then we can actually do some kind of straightforward analysis and say, hey, does the accuracy rate of these models differ according to group membership, right? Is it more accurate for white defendants? Is it less accurate for black defendants? This is an example that we might hear about. And there, it provides us a pretty obvious way to begin this conversation, right? Differences in accuracy rates are problematic, right? We would want to actually suggest that at the very least there should be some equality in the accuracy of the decisions regardless of your group membership. But as we go down this list, the problem becomes much more difficult, right? So when you have skewed examples, the way we validate models is to use an add a sample. You know, we set aside some data, we try, well, we know what the predictions, the accurate prediction would be. But the problem here is that if the data used to train your model and test your model all suffer from the same bias, meaning the same sampling bias, then it's going to report high accuracy despite the fact that one actually deployed in the real world, which is not actually going to look like your skewed sample, the true accuracy of this model will be much worse. But you don't know that. We don't have an obvious way of even knowing if the reported accuracy is correct. And this is even worse in the case of these tainted examples, right? You have no way of knowing that your model necessarily reproduces the bias or implicit, the prejudice or implicit bias exhibited by the human decision maker that labeled these examples, because again, from the perspective of the machine learning task, that's what it thinks is true. There's no one telling it that those things are wrong. So this is a much more difficult problem. And interestingly, this concern where we have features that are highly predictive of some outcome, but also happen to correlate with your group membership, it really depends on how you view this problem. If your view of this is that, well, this necessarily is objectionable because it's a stand-in for race, well then, you know, that invites some kind of conversation. But if your view is like, well, no, we've established definitively that despite the fact that it's highly correlated with race, it happens to be a perfect predictor of this outcome, And this invites a kind of more complicated conversation. For instance, why is this a good predictor, right? If it happens to be highly correlated with race or gender or these other protected characteristics, but also a good predictor of this thing, you might want to know why that it is. And if you probe a little further, you might discover that the reason that it is something that's self-objectionable, right? And then finally, as I mentioned, the real problem here with these kinds of inferring race or gender is that it will just be very difficult for us to detect because we have no way of actually knowing that this person behind the scenes has gone about inferring it. Okay, so let me just now say a little bit that makes this less, I don't know, depressing. Many of the people in the community I introduced you to are not simply trying to identify and diagnose these problems, although that is a big part of the community as well, but they're also trying to develop solutions to address the different problems I've described. So for instance, a considerable amount of work in the past year has focused on how do we formalize problems where there are differences in the performance of models across groups, and we know that. Where the data, for instance, we take the data to be a true representation of the distribution of some property in the population, but we want to ensure that there isn't these disparities in the accuracy rates of these models. And so a lot of people in this area have tried to figure out how do we improve the performance of these models for instance, a minority group, while making sure that we don't do it by simply, how do we equalize performance across these groups, but not doing it in this incredibly naive way where the obvious solution would be to just reduce the accuracy of the model for the majority group, right? We want to figure out ways to improve the performance of these models for the minority group while maintaining some degree of high performance for the majority group. People have also begun to look at how some existing methods within largely operations research might be useful for discovering the true base rate of certain kinds of activities in society, and that involves doing these principled experiments where rather than just accepting that the data we've collected is going to be a good representation, we continue to actually experiment rather than deploying police only to the places where our model currently predicts we should deploy them. Maybe every once in a while we should send them somewhere else to discover if our observations actually disprove our current best guess that there isn't crime happening there. And so there's considerable work that's coming in from operations research and largely actually involved in things like reinforcement learning and other things like that. The most difficult problem, and the one that I think is probably the most politically charged, is this case with tainted examples where we don't really know what the true label should have been because it's been affected by the subjective human assessment, right? And here, there's no purely tractable mathematical way to actually definitively clean it, or whatever taint the data might have. And instead, what people have largely tried to do is to try to figure out how do you minimize the disparity in outcomes given that we believe that there is some kind of taint, right? So this is a slightly different problem where you want to adjust the distribution of the outcomes to reflect what you believe to be the right thing, or what would have been the appropriate assessment in the absence of human prejudice or bias. And the final thing I'll say is, what's nice about these techniques is that whatever might work for these unintentional cases will by necessity also work for the intentional ones. So if you put these things in place, if you put in place these tools to deal with these unintentional cases, you will also make it practically difficult to actually do things intentionally as well. Okay, and the last thing I'll just say about all this is that there are, interestingly, some tensions here. There's tensions between different ideas of what counts as fairness. Some things are trying to make sure that similar people are being treated similarly. Some things are trying to ensure that different groups across society achieve similar outcomes. These can often be in conflict if you think, for instance, about policies like affirmative action. There could also be a tension between fairness and accuracy. So trying to withhold information that is highly correlated with race, for instance, can in fact reduce the accuracy of the prediction you're making. And you might think that's acceptable depending on your view of the problem. And here too, there's also questions about what method is appropriate for doing this. Should we intervene in the way we transform the data? Should we intervene in the process of learning from data? Should we do something at the end of the process to kind of rebalance in ways that we think are appropriate? And all of these, I think, involve really important technical but also policy discussions. And this, I think, is the area that's in most need of an infusion of outside voices, not just people from computer science, to really understand how to think about this, not purely as a technical problem, but one that requires input from policymakers and really people who can think about this as normative issues specific to different domains. So I think I'll just end there. Oh, the very last thing is we've also have this conference, which is meant to be a way to kind of expand the scope of this discussion, not just narrowly focused on machine learning, but broadly across computer science, where there are many people who have begun to think about these issues. And the hope is that we can bring those people together at an independent conference that will happen in New York in February, where despite whatever your home subfield might be, this will be a place that we can meet every year. And this would involve people not just within computer science, but a much broader set of people as well. So for those interested in this issue, I encourage you to consider coming or to come speak to me, and I'd be happy to tell you more. So thanks very much.
Let's see if I can get the slides up. Maybe? Great. So I mentioned in the introductory remarks the Wired article that basically calls for kind of the end of black box algorithms. It's often very hard to figure out why an algorithm produces a particular result. So our next speaker, Professor Nick Diakopoulos, is it pretty good?
We'll give it to you.
Okay, thank you. We'll specifically talk about why algorithm accountability is hard. He's an assistant professor in the School of Communication at Northwestern University, which I also found interesting because his PhD is actually in computer science from the School of Interactive Computing at Georgia Tech. So again, one of those interesting interdisciplinary type of careers. He's also a Tao Fellow at Columbia University School of Journalism and Associate Professor too at University of Bergen, Department of Information Sciences and Media Studies. And I don't know if there will be questions about this during the question session, but I am definitely very curious. So he co-founded the program in computational journalism, which sounds like exactly one of those programs that you would want to kind of bring in together experts from diverse set of expertise. So with that, let's welcome Nick.
So, hi everyone. Thanks for the introduction. Nick Diakopoulos from the School of Communication at Northwestern, where I study methods for ensuring algorithmic accountability, including methods for investigating algorithms, as well as for ways for thinking about how to make them more transparent through sort of targeted information disclosure about how they're working. I don't know to what extent I need to sort of do much convincing around the idea that algorithmic decision making is sort of pervasive throughout the public and private sectors now. We can find examples throughout housing, throughout credit, employment, criminal justice, and a number of other scenarios. Algorithmic accountability, this idea kind of gets at the question of how to investigate these systems, these algorithmic decision-making systems, and try to explain these systems to the public, to other stakeholders, and try to start characterizing the types of bias that Solon was talking about, but also more generally how power is exercised, how influence is exercised through algorithmic decision-making systems in society. This could include things like identifying cases where algorithms are contributing to discrimination, as this graphic from ProPublica shows, this was an investigation that they published last year, or rather earlier this year, looking at insurance rates in different neighborhoods in Chicago. Actually, they tested this in 4 different states, and they found that higher auto insurance prices were being charged to people in predominant minority zip codes, while still controlling for sort of the risk, the overall risk factor of getting into an accident in those zip codes. That's just one example of an algorithmic audit, sort of in this vein of algorithmic accountability reporting. There are, of course, other examples like this. ProPublica has really sort of built a beat around this. I would encourage you to look it up if you're not familiar with it. It's called machine bias, and there's sort of a whole series looking at algorithms in different domains, including sort of a high-stakes example of risk assessment algorithm that they evaluated and sort of audited that's in use in Florida, and they also found racial discrimination there. So, you know, journalists as well as other academics are sort of engaged in this field. You know, I've done work looking at, for instance, auditing Uber service quality in different neighborhoods in New York, as well as looking at things like diversity of search engine results as it relates to news. And I should mention, algorithmic accountability isn't just about discrimination. It's also about sort of other types of consequential errors, things that might violate people's rights to, say, due process. So there's sort of different sort of newsworthy aspects of algorithms that we could talk about. So this is kind of a long introduction to get to what I'd really like to focus on for my talk today, which is I really want to talk about why these types of algorithmic accountability investigations are so challenging to do. And I sort of have five points that I came up with. And in particular, I'm going to focus on this from the point of view of a third-party investigator, so someone who's external to an organization or entity who's trying to peer into the black boxes that are being used in that organization from an external point of view. There are, of course, other types of auditing models that have been proposed, but I'm going to focus on the perspective of the third-party external auditor. And certainly looking forward, some of these challenges, I think, warrant additional technical research. Others will demand interdisciplinary and multi-stakeholder efforts, including bringing in various stakeholders from legal domains and policy domains, thinking about different forms of regulation or how we need to update existing forms of regulation. So I hope my presentation here will provide a little bit of fodder for thinking about potential interventions along these dimensions. So let me dive into information deficits, my first point here. So what do I mean by information deficits? Well, what I mean by that is really, you know, when you're investigating an algorithm as an external entity, there's a real severe knowledge gap that limits your ability to even begin auditing a system. You know, we try to make do with what's publicly accessible, the dribs and drabs of information that might come out of organizations in the form of blog posts or interviews with journalists, or sometimes, if you're looking closely, patents. Sometimes even things like the variables or inputs that an algorithm pays attention to may be obfuscated, and so it's difficult to know where to start. You know, what variables need to be controlled for if you're auditing a particular system. And this can lead to issues, attribution errors like omitted variable bias, which, you know, could make it appear as if one variable, like race, is more predictive of outcomes than it may actually be. Understanding and explaining why an algorithm has made the decision it has can be extremely difficult in these types of observational studies. And so other methods need to sort of supplant sort of quantitative sort of audit types of methods like interviews. These can also help to shed light on system behavior by understanding sort of the internal perspective on how people are integrated into the system, for instance. Many external audits will be limited to description and characterization, which is a little bit of a bummer because it's just extremely difficult to try to explain why you're seeing the result that you're seeing, given the information gap. If we cooperate too closely with the target of an audit in order to narrow our information gap, we also potentially run into issues of independence. The target still ultimately controls the information disclosure and can therefore strategically shape the interpretation of the system by feeding particular bits of information to the auditor. So I think that to truly uncover how an algorithm may be functioning requires sort of a delicate dance between the target and the auditor. And while, you know, I wouldn't say it's a silver bullet by any stretch, I believe that regulated transparency policies may actually help with some of these issues associated with information deficits. So sort of regulating that this, and this are pieces of information that have to be disclosed about algorithms being used in particular domains. The second point I want to make is about algorithms as socio-technical assemblages. So algorithmic systems are socio-technical in the sense that they're comprised of both the algorithm itself, the technical object, and the people who are sort of closely entwined with that algorithm, either the designers or people who are working with it in an ongoing way. One algorithm may make a prediction that's interpreted by a person and then fed back into a different algorithm whose output finally lands on the desk of a decision maker, like a judge, for instance. In some cases, algorithms may be advisory, while in others they're more autonomous, but rely on an assemblage of people that support that autonomy in a variety of capacities, such as producing and cleaning data. Many systems have a lot of human feedback into them, raising challenges related to the diffusion of responsibility throughout a system. So for example, when search autocomplete algorithms suggest terms that are risky and or normatively or legally inappropriate, a common refrain from technology companies is to blame the people whose raw inputs to the search engine were mined in order to make those suggestions in the first place. So whose fault is it when a search engine suggests terms that lead to child pornography? Who's responsible? The law may have things to say about legal liability, certainly, but ethically and also, I believe, philosophically, there are still some open questions about the apportionment of responsibility in these deeply socio-technical systems. Temporal instability. Algorithms have the potential to be highly dynamic. Of course, they can also be relatively static or slow-moving. And this temporal indeterminism creates practical challenges for monitoring these algorithmic systems. Google typically changes its search algorithm 500 to 600 times every year. But the city of Chicago is on only version 5 of its strategic subject list, a predictive policing algorithm, in as many years. Randomness can be a component of the output of an algorithm, and so this, if the system never gives the same answer twice, we need to have probabilistic representations of behavior and so on. In order to assess these systems, we also need to monitor them over time, right, and be able to put probabilistic bounds on behavior over time. What's the right sampling interval for monitoring? If I don't know how often an algorithm could potentially update, it's difficult to know how often to sample that. If an algorithm is potentially changing very quickly, we may need to develop, in turn, more dynamic ways to present the results of an audit. News articles or research papers, sort of the dominant mechanism for us talking about audit studies, currently they capture a snapshot of behavior around an algorithm. But this may be wholly inadequate to convey information about algorithms that sort of are highly dynamic or that demand routine and ongoing monitoring. Expectations and expectation setting. If algorithms never violated our expectations for their operation, they would be pretty unremarkable. So we need to be able to define our expectations of the behavior we expect from algorithms in order to begin to create norms of operation around these systems, and articulate ways, different things like how they handle errors or in terms of how and whether they treat people fairly. Violations of norms become opportunities for accountability, for an explanation of the nature of that violation. Oftentimes, expectation depends a lot on context. And so each scenario where an algorithmic decision is in use may spur a different set of expectations. And this is where the domain specificity, I think, is very important. What we expect from behavioral algorithms is going to vary from case to case. I have very different due process concerns when an algorithm scores someone in the criminal justice system versus when one charges me a different price for an airline seat, for instance. Definitions are extremely important for setting expectations. A fairness definition might be based on group-level fairness, or it may be based on a definition relating to equality of opportunity. And this raises political questions like whose definition is right? Which one are we going to agree to be the benchmark, the expectation for the algorithm? to test its behavior against. So this quickly becomes a political question. I think expectation setting for algorithms will need to be very well reasoned and well rationalized and put into an ethical framework. And I think ultimately we're going to need to figure out ways as a society where we can start to have processes for building consensus around the definitions and how they're operationalized for each individual sort of scenario or context where we're deploying these algorithmic decision-making systems. Finally, I want to mention some of the legal friction and legal barriers that come into play when trying to investigate algorithms as an external party. This is a big one, particularly for journalists who are investigating algorithmic decisions. Public records requests and public records laws are not necessarily well equipped to cope with the needs of investigating algorithms. Guidance from individual agencies in the federal government is quite inconsistent. Some agencies, like the Social Security Administration, claim that software or source code is not foiable because it's not, quote, an agency record, a vague term that is not defined in the law. Another challenge is that FOIA requests can be rebuffed on account of any of 9 exceptions. This is, of course, at the federal level. States have their own FOIA laws. One of the exceptions is exception number 4, which is not infrequently cited exception used to reject a request because it conflicts with trade secrecy rights around the government's use of a third-party proprietary algorithm. I've done projects where we've tried to FOIA criminal risk assessment algorithms in all 50 states, and this exception, this trade secrecy exception, came up about almost 20% of the time in responses that we got from various states. Finally, I wanted to mention the CFAA, the Computer Fraud and Abuse Act. This is a statute that potentially creates a chilling effect on the ability of not only journalists, but also researchers or others who wish to audit algorithms online. This statute suggests that a terms of use violation may form the basis for liability under the CFAA. And because many terms of use contracts prevent things like web scraping, prevent things like the use of fictitious user accounts or sock puppets, this makes auditing techniques potentially liable under this statute. And so I believe that certain types of regulatory reform need to happen and are necessary to really enable algorithmic accountability in society. So I'm going to end there, and I'm happy to be in touch. Here's my contact information. I also want to point out a project that we launched earlier this year called Algorithm Tips, algorithmtips.org, where we've created a database of algorithms that are in use in the federal government, which may warrant additional investigation. Feel free to check it out and look through. We have more than 150 examples there, and we're looking to expand it both nationally, internationally, and localize it down to state and city level municipalities. So thank you very much.
Okay, and our last panelist is Kelly Jin. So it's interesting, there's a lot of discussion on the need for policy engagement. So Kelly currently serves as the Director of Data-Driven Justice at the Laura and John Arnold Foundation. But before that, she served as a policy advisor to the US CTO and Chief Data Scientist in the White House, OSCP. Before that, she built and co-led the City of Boston data analytics team, where she oversaw a portfolio ranging from public safety to housing and led data visualization for the city. So let's welcome Kelly.
Thanks, Nadia. So we're going to do a quick activity because I see a few heads nodding in the background. If you guys could all just stand up for me, please. I know. Yeah, panelists too. Also, we're live streaming, so this is great. If you guys could raise your hands. I see some hands being raised already. Yeah. I think you guys can reach a little, just like, you know, get on your toes, kind of like. All right, so collectively, together, just on the count of 3, we're just gonna go a little bit higher. Okay, 1, 2, 3. Perfect. So the point of this is that we can always reach a little bit higher. You can all take a seat. So I am so excited to be here. I think a few things that are top of mind for me. I was reading this portion right here, addressing national priorities and societal needs. And for me, this is really about, I think from my own personal experience, understanding what's happening on the ground, what are practitioners struggling with, and what are policymakers trying to accomplish oftentimes on the ground. And so I think this presentation for me, I've been told to A, keep it short, and B, also be inspirational so that you guys feel like there's areas that we can all push forward on. So without further ado, I'll just kind of launch into the presentation. If you were to look at this map, and kind of think about this broad question of if I were to ask you what the 3 largest mental health facilities are in the United States, some of you may raise your hand and you may say, well, those are probably hospitals or actual mental health facilities. And you would actually be completely wrong. So I've run this a few times with different audiences. The largest mental health facilities in our country are our nation's 3 largest jails. So this is representing Rikers, Cook County, and LA County jails throughout the country. And so for me, I think a lot of the work that I've been doing and really proud of being on different teams is how can data help in these situations, right? So for us, this is really a starting point for us. And so when you look at some of these numbers, every year there are about, let's say, give or take, about actually 11 million people who cycle through around 3,100 local jails in our country, at the very minimum costing us just in jail services alone about $20 billion. If you look at the actual impact, I'm speaking to the perfect audience for this, if you look at the actual impact to families, to our communities, that number is much, much higher. And so for me, I had really the privilege of being at the City of Boston and City Hall, but really thinking through what are some ways, in my return to Washington, D.C., what are some ways that we can start tackling this national priority, if you will, really in the world of criminal justice. And when you unpack some of those numbers even further, for those of you who your jaws may be on the floor at this point, of those individuals who are cycling through those local jails, these are what, I don't have to read these numbers, these typically are what the numbers are looking like. And so we have a lot of individuals, oftentimes low-level offenders, who are cycling through. And from our perspective, it has always been, whether at the Arnold Foundation today, or my work at the White House Office of Science and Technology Policy, or even before that at the City of Boston, our work is really centered around how do we find models of what is working throughout the country, and how do we actually scale that. So that's something that I'm constantly thinking of in my mind, and I think my respective panelists are thinking of this as well, is that as we're thinking of potential solutions, how do we scale, and how do we caveat a lot of the challenges that people are actually facing on the ground. And so particularly around this issue of individuals who are cycling through our systems repeatedly, a great example of a case study is Miami-Dade, Florida, actually did a very simple thing to all of you, not in actuality a very simple thing. They looked across all of their data sets of public health, law enforcement, et cetera, and they were able to find just 97 people, these are some of the high-level numbers, who had cost over the period of their lives at least $13.4 million in services, and collectively had just served just quite a few numbers of Dales in institutions. And so for them, it really became, what are some of the ways that we can tackle these issues? And I'm telling you guys these stories because For me, I think on this panel, I think particularly at this conference, there's a lot of work being pushed forward nationally saying, how can we better assess risk, right? How can we use algorithms? And I think there's always this other piece, which is, well, then what, right? What do we do with the actual individuals who are identified, or what do we do with the actual decisions that are being made? And so for us, a lot of that is also, how do we connect that to intervention? So Miami-Dade, Florida, they were able to do really, really incredible things like actually implementing crisis intervention training, actually building out crisis stabilization beds to reduce their jail populations and reduce these numbers. I say all of this because I think to this audience, in my mind, something I'm constantly thinking about is how do we connect technologists, data scientists, computer scientists with policymakers, right? So for us, oftentimes at the White House, is making sure that we brought individuals into the room from day one so that we never got into a situation where we're moving forward on a technology or on an algorithm or have made decisions without consulting the experts. And I can definitely promise you I'm going to be calling Solon and Nick after this panel, if not immediately after the panel, to talk more, right? Because I think for me, a lot of the bridging, I think there's so many different conversations I've had actually. I have delivered a similar talk to very different audiences in the last 2 months, and I think there's very much a national conversation being had on all of these different areas. But for me, there's oftentimes this missing piece, this missing link of how do we actually move this forward on the operational local government level. And so, what did we do, right? This is about solutions. What did we do around this national priority, national issue? We banded together 143 communities across the country, really with that commitment that A, they understood that individuals were cycling through their systems, and B, they wanted to actually divert those individuals out of the typical criminal justice system. So when you guys saw a lot of those graphs at the beginning, just think about delivery of services. Can we connect those individuals to get mental health services with mental health clinicians instead of having to cycle through back into jail? I'm seeing a few heads nodding out there. So that was really top of mind for us. The piece that is sometimes the question here is, what does that have to do about data, right? So I think for us, local government is oftentimes so incredibly caught up in the inability to make any sort of decision, right? And so for us, that ability to use data as the first step is oftentimes very earth-shattering for them. I think for us, there's still a ton of work that has to do with information intake, and that has to do with how do we unlock a lot of the information that is, in my knowledge, sitting oftentimes on some walled off laptop in some basement that is actually carrying a lot of information that could be better used for making decisions. And so for me, I wanted to share, I'm totally running over my time, but wanted to share with you guys how I think at a really, really high level at air services and delivery of services within local government. It is all about how can you hit at each of these different issues, stakeholder buy-in. For us, it's assisting high utilizers and then actually connecting that to interventions and delivery of services. The big piece here, which you heard all of the panelists already talk about, is how are you measuring the effectiveness of these programs, right? And how are you measuring the effectiveness of those algorithms being used? Because I think something that I've continued to repeatedly learn over time with government at all levels is that it's really hard. It's really hard to A, measure the current state, and B, be able to tell a story of how you've actually impacted that by changing policies. And I think in the 21st century, oftentimes those policies are, can we use technology and can we use data to make those decisions better? I'm going to go probably 2 more slides. I'll skip through the majority of the rest of the presentation. This is something that I know is a little bit hard to see, but we'll definitely share these slides. This is a slide that we received from Lieutenant Dan Wagner from the Cambridge Police Department. And Dan, he works, he's a police officer there, and he does so much work out on the ground, out in the field, through patrol. And something that he told us, and that I already kind of explained and previewed for you guys around data-driven justice specifically, is that we lose opportunities to deliver interventions, right? We lose opportunities to connect with individuals because oftentimes our systems don't talk to one another, and oftentimes those individuals within those systems don't talk to one another. And so for me, I think, there's a little bit of a call to action to this group, is that in our attempts to trying to find what those points of intervention are, how can we do that effectively, right? So we talked about the ability to FOIA the government, public records requests, but for me and a lot of this work, this is protected data, right? This is HIPAA, and how do we deliver better services when we can't even touch or get access to this data, or if there are a lot of ramifications in the ways of who can touch the data and so forth. So I think in my mind, if you read through this, it's really, we're missing opportunities at the law enforcement level as well as at the EMS side. This doesn't show other encounters that this individual has had at the hospital, et cetera. There's a ton of pieces here that I think, again, my call to action to you guys is really about how can we implement this on the ground? How can we better understand and elucidate some of those risks? So I will skip through that really quickly to jump to my very last slide, which is, again, this is all about, to me, what is happening on the ground. And so in our endeavor to figure out who some of these high utilizers are, working in partnership with local jurisdictions, specifically in Iowa City, we were able to work with Dave Schwint, who's a lieutenant there on the left-hand side. He does homeless outreach. And we found this really, really interesting data point, which was that Alan, who's on the right-hand side, he actually had only gone to jail once in the last year, but he had been, 911 had been called on him 69 times. And so for us, we were looking and we said, this is really strange. Is he a high utilizer? Because you guys aren't actually, he's on one side, there's only just one jail booking, but on the other side, you guys are getting called a lot. And so Dave wrote this nice note back, which I think really is a state of where we are today, right? So we're able to work on, it says very briefly, Alan, the man you referenced below, has all these different problems. Unfortunately, we haven't found a way to work with Alan. That's why you don't see him getting booked. We try to take him to our low barrier shelter when it's available, take him to get showered, et cetera. We rarely arrest him. If there was something that worked to help Alan, we would do it. We just don't know what it is. And so again, I think this is particularly Nick's point during his presentation, is that in local government and in policymakers' attempts to derive and build solutions that we can help Allens across the country, how can we do that in a really, really smart way, right? And how do we actually bring together the right individuals to have that conversation? I think that is, we're already having it in 2017, and my hope is we'll continue that in 2018. I hope this is informative for all of you. My hope is that you talk about this at dinner and happy hour later today, because I think there's a huge piece of this is just sharing a lot of these overarching issues that aren't just restricted to criminal justice or health, but across a whole slew of other areas as well. So thank you guys.
So we have time for some questions. I wanted to start with kind of a quick question to everyone. Don't go away, sir. It'll be super quick. So I'm curious from your perspective, and whether it's a policy perspective or an R&D perspective, given that this is national priorities and there's a number of agency representatives in the audience, what do you see should be some of the higher priorities for some of our federal agencies, whether it's an investment in a research agenda or a policy? And maybe Solon, you can start.
Sure. So to pick up on a point that Kelly made, which I thought was a really important one, is we really don't know how to evaluate some of these things. Arnold Foundation is exceptional here, but there are a lot of private vendors that are beginning to sell a lot of these tools to government at every level, and it's often hard for these people who are contracting to understand what to make of these claims. And it would be great, for instance, even if there was just some guidance that was issued. For instance, like I could imagine DOJ issuing guidance about what is good practice for evaluating the claims of tools that are being adopted at state and local levels, right? To me, that feels like a very obvious win. It seems like something the DOJ would be well prepared to do. Separate from that, I think there's like a real need to, from a sort of like a research investment perspective, to incentivize much more meaningful and deep interaction between people in computer science and policy and law. So grant making here really can't be siloed. It shouldn't be something where like this becomes a field that is primarily dominated by computer scientists. There should be resources made available that are specifically for people who are doing interdisciplinary work. And I recognize that can be difficult for the NSF, but in these key areas, this seems like one area that we really need to kind of do that.
Yeah, and I guess I would just pick up on that. I think, what could be a priority would be investing more in developing rigorous sort of methods for assessing these systems. I think, even with the best of intentions, certainly you can have unintended consequences, and I think we will always want to have a set of stakeholders in society who are empowered and enabled to poke and prod these systems as independents. And I would cite something like the VW case as an example of why that's important, right? I mean, there's a whole regulatory regime around emissions, and it kind of fell down to some researchers who were, doing their own assessment of those emissions to find that. And to sort of pick up on what Solon was saying, I think looking at these types of audit methods in particular domains, in particular cases, and partnering with people who have expert domain knowledge of those systems is really important. I found in my own work, it's impossibly hard to come up to speed on the complexity of some of these systems, and it's a lot easier to talk to someone who is already kind of embedded in that and wants to sort of collaborate on some type of audit.
And just to kind of double down on what these guys already said, I think there's a huge procurement, there's like a huge procurement piece, right? So if there's, one of my former federal agencies was GSA, I think there's a huge piece that could be done for those of you from federal agencies on better understanding and asking the right questions as part of the procurement process at the federal level, and I hope that can get translated to the state and local level. I think one other thing I'll add is I think at the national level, there are over 175 graduate level data analytics, data science programs at this point. I think there's beginnings of this movement, but really ensuring that data ethics is a part of every single curricula that has to do with the next generation of individual students who are working on this. I think increasingly, and this is something I heard at another conference that I was at, was what do you do when people are a little dangerous? Like they understand a little bit, but they don't have that formal training, right? And I think that increasingly that ability to, whether it's these two guys who are going to do a course together or something that is ensuring that is a part of the day-to-day as people get up to speed and hopefully become the next generation of policymakers, I think that is really, really top of mind for me.
Please say your name and affiliation.
So my name's Mark McCarthy. I'm with the Software and Information Industry Association and also with Georgetown University here. And I want to thank you for this panel. It was great. This is just the kind of stuff that is of broad interest to the public and to policymakers. And I want to endorse Solon's call for involvement in his organization that really does embody many of these interdisciplinary approaches to the problem. And of course, guidance from federal agencies would be excellent in this area if we could get them to do it. My question really goes to the problem that Solon pointed to with the relevant variables when you're trying to assess systems Very often, trouble arises when the system produces a disparate impact on protected classes, and often that can be traced to different distributions of relevant characteristics within the different populations. Men and women differ in various ways, the races differ in various ways. The famous recidivism score that Compass developed explicitly takes gender into account, and it does it because they say it's fairer and more accurate to women who have lower recidivism rates than men do. So how do we deal with these questions when the relevant characteristics differ by population? Is it a technical question where we can manipulate the data or the algorithms and produce different outcomes? Is it a normative question where you have different points of view about what the right answer is? And to what extent could these things really be addressed only within the context of programs for social change? You need to change the criminal justice system, you need to change the education system, and trying to address it solely as a technical problem of algorithms may not be the way to really address the full scale of the problem.
So I can take a first pass at answering the question. I think in my mind, it cannot be just a technical response, right? I think that is, you heard that loud and clear from all three of us. There needs to be, at least in my mind, an understanding of, I think oftentimes I am working to help translate a lot of that to policymakers. So I think there's a huge piece there that is really on what is underlying, right, outside of the questions around openness and transparency around the algorithms, but even just explaining to a policymaker of how are we making these decisions today, and how are we trying to make those decisions, or how should we try to make those decisions tomorrow. I think that has been really top of mind for me, and in very kind of layman's terms around that. Like, how do I explain that to an audience? How do I explain that to the public? I think there are quite a few bridges there that I have not really seen good examples of that being done, and it's something that I know that at the Arnold Foundation we're working on, both in funding that research, but also a lot in the communications pieces. I think particularly for local governments, them being having to be really accountable to their citizens and to the public, as all governments should be. How do you explain to the public? How do you explain to civil rights, to advocacy groups, what exactly is being done? I think there's a huge piece that's oftentimes just lost in translation around this, but I'll turn it to these guys too.
I would jump in and just say, I think there are interesting technical questions here, but for me, it seems like the policy questions kind of overshadow those to some extent. You mentioned, what are the relevant variables, and might those differ by population? I mean, define relevance, and relevance depends on the particular context and scenario of decision making. And how do we define relevance? Well, I don't know, we have to come up with some consensus building process whereby we talk about which variables we think are relevant for this model. And that is, I think that's just perhaps a process that we haven't fully kind of fleshed out and understood in the domain of model development. And so to me, that's less of a technical challenge than a people challenge.
So that's a great question, Mark, and I'm not surprised that you would raise it. So the example I offer here to kind of drive home the point that I think you're raising is something like this. You may recall the example I gave of like the annual evaluation of employees being tainted by the human subjective decision maker. But let's imagine a situation that's slightly different, where the score actually reflects like faithfully how this person performed, but that the environment itself was very hostile, or that there were conditions in the workplace that made it such that certain people were much more likely to succeed than others. So you can say that this was an objective measure of how people performed under those circumstances, right? And so this is trying to get to your point, right? If we see this problem purely as a question about observational data and not about like the background conditions that allow us to make predictions, then we can get stuck. But if we actually probe further and try to figure out like well, what else are we in a position to change besides the decision about who to hire in the future that will adjust whether there is some disparate impact? Right? Maybe we actually have to reform the institution rather than just making sure that the decision-making process somehow is fair, right? I mean, I even use this in the class I teach. I tell students, like, you know, I build a model that tells me, like, who's going to do best in the class, and then I'm going to use that to decide who I let to, like, you know, come into my class. The students immediately recognize that, like, that is not just a function of their innate aptitude. I also might be really bad at teaching certain kinds of students, right? There has to be, like, a recognition that this is not just about the decision-making, this discrete moment decision-making, but reforming other parts of the process that will change how people do under those circumstances.
Hi, I'm Lindsay Barrett. I'm with the Future of Privacy Forum. I'm a lawyer, and you've all spoken very eloquently and convincingly about the importance of interdisciplinary collaboration. And actually, part of this is a plug. I co-founded the Georgetown Law Technology Review, and we publish technology explainers and are always looking for computer scientists and people who actually know what they're talking about to write them for us. So while I'm no longer affiliated with it, but please submit to that. And my actual question is, what are the biggest mistakes that you see in people, in rather non-empirically trained people writing about these problems? And apart from just learning more and hopefully educating ourselves, what would your suggestions be?
I can again try to start answering that, which I think from my perspective, which is really on the ground, I think an understanding of how the systems operate today and how the processes happen, whether that's criminal justice, whether that's health, education. I think that is where, I'm just thinking in my mind, having, in Boston, we had a Harvard PhD student who was looking at street parking data, and he had done all this great analysis, and then he finally got out into the field and went for a ride along, and he said, this has totally changed every single perception that he had on, that he knew what the, let's say, how the public would perceive or was likely to perceive doing variable priced parking as a good example, right? And then he went out into the field and talked to a few folks, and he said, well, wait a minute, okay, the insights that I've derived, that is important. I looked at the data, I did the analysis, but I really have to go out there and actually speak to the public, speak to the individuals who do this day to day. I think that's something that I'm constantly, again, going back to students and how do you train and how do you teach around this, ensuring that people understand that, again, it's not just that analysis by itself, but it's ensuring that you're partnering that with an understanding of what's happening on the ground. I think that's tremendously important in the criminal justice system, which I am still relatively new to understanding, and it feels like every time I pick up a rock, I'm like, oh, there's like 50 other rocks, and oh, these are statistics that at an aggregate level may be shocking to folks, and then trying to unpack what that means at various different layers below. So yeah, just in quick summary, I think, again, that partnership, and you know this at Georgetown, right? A lot of the work right now is at the intersection of technology, policy, and law. And that is really in both data-driven justice and I think in all of these different policy areas, the nexus that has to occur in order for us to move forward in the field. Yeah.
So I'll say something that maybe not what I would normally say, but while I've been really excited about a lot of the media attention these issues has garnered in the past couple of years, there feels to me a little bit of a frenzy at the moment, such that any even potential bias in these systems is seen as cause to discount it completely. And I worry that that is also the position that will be adopted when, in fact, adopted by people in the policy and legal world. And I think what's really needed is like a way of understanding this in a more comparative way, right? Like, given what the existing way of making these decisions happens to be, despite the fact that we can probably begin to interrogate more rigorously the bias that these exhibit, how does this actually still compare to what's in place now? And that's not to say that that should be a way to like brush aside any concern with bias, but it should be a way to force this conversation to be a bit more nuanced, right? That we shouldn't accept that just because we can clearly identify bias in algorithms, that somehow that means they're way worse than letting humans make decisions. So.
And I would just chime in and say, maybe not a mistake in terms of media coverage, but certainly a challenge is sort of going up against entrenched industry definitions of the way things should work. I'm sort of reminded of ProPublica's work looking at the Compass risk assessment tool. And really at the end of the day, if you've taken the time to read all the back and forth between ProPublica and Northpoint and back and, sort of other industry groups chiming in to criticize ProPublica and so on, kind of what it comes down to is like a difference in definitions of what fairness should mean. And the industry has one definition of fairness, and they're like, we're calculating accuracy this way, and it's fair according to that definition. And ProPublica is like, yeah, but you forgot about like this other definition of fairness. So sort of going up against that, and we see this in other examples as well. And the other challenge I would say is sort of missing context. So, just to kind of pick on that example a little bit more, the human influence in terms of how risk assessment scores are interpreted and applied, I think while it doesn't necessarily undermine sort of the importance of looking at the score itself, I think perhaps it does mitigate sort of the potential implications, because in fact the system is a man-machine system with some judges who are sort of dismissive of the score.
Okay, so I think we have 2 minutes. So do you want to ask your question, and then we do a really quick round of answers and any closing remarks?
Sure. I don't know if this will actually be a quick response, but I'll
Your
throw it out
name
anyway.
and
Yes. Eric Bulmer, Lehigh University. Thank you. Great panel. I want to suggest, if I may, that it would be interesting to consider this panel juxtaposed with the panel yesterday on augmenting human capabilities. Because a lot of what you're talking about, particularly in Nick's response about human-machine systems, really has to do with questions of not what does this data analysis or classifier do per se, but how does it become embedded in and involved in these, to borrow your term, socio-technical assemblages. And I think taking that perspective, I would be interested to hear how each of you would respond, thinking not just, again, about the technical details of the system, but about the larger systems of which those technologies are simply a small component.
In 30 seconds or less, please.
Yes.
Very quickly, I think this point about judges actually being given these scores and then investigating empirically how they actually act on them is a massively important question. There was a recent Wisconsin State Supreme Court decision that went to the Supreme Court here that was kicked down. Anyway, the outcome there was actually probably the worst of all possible outcomes as far as I'm concerned, because what it had said is judges should not rely exclusively on these scores, but they should take into consideration other things they can, think about. Which should allow things like this. If it confirms my suspicion, I'm going to use the score, and if it doesn't, I'll overrule it, right? That's not a good outcome, and we should study those kinds of things empirically.
Yeah, and I think it comes back to, how do you evaluate these types of systems? I think we need to get a little bit smarter about not focusing just on the black box, but coming up with evaluation methodologies and regimes that allow us to understand components, different sets of black boxes in conjunction with people and working in sort of soft algorithms of bureaucratic processes.
And I'll say, just in closing, I think the answer to poor data or questions about how we're implementing algorithms should not be no data and no use of data. I think that is, as we have talked here on the panel, just something that we are oftentimes making decisions without any data, and so a lot of my work is still just on the front end, right? How do we figure out just providing more information to individuals? I think that is not exactly the augmenting of abilities, but just something that I'm still trying to unlock a lot of information around the criminal justice system itself. So.
Okay, let's thank all of our panelists.